Alright, the last section we're going to focus on for this, we're going to take what we just talked about with polar coordinates and talk about how to graph polar equations. So in this section we're going to be looking at, well, I just literally read the same thing, sorry. The first thing we're going to try out is sketching the graph of the polar equation r equals 4 times the sine of theta. Now I'm giving you a table here where we're going to plug in different theta values and we're going to see what we can get. Now let's just start off by plugging in theta equals 0. We got r equals 4 times the sine of 0. Now if you don't know, let me adjust the screen a little bit. There we go. Now if you don't know what the sine of 0 is, we can always go back to our unit circle. And the sine at 0, remember, we look over at the y coordinate and we see that the sine of 0 is, well, 0. So, going back to this, we got 4 times the sine of 0, which ends up just being 4 times 0, or 0. So the r value, our radius there, ends up being 0. Plugging in pi over 6, we got r equals 4 times the sine of pi over 6. Again, going to the unit circle, we look at pi over 6, we see the sine as 1/2, so we end up with 4 times a half, which is 2. Next up, r equals, sorry, I'm not on screen right now. There we go. R equals 4 times the sine of pi over 3. Now in the unit circle, we go to pi over 3, and we see the sine at pi over 3 is square root of 3 over 2. So that ends up giving us 4 times the square root of 3 over 2. If we were to clean that up, that ends up being 2 square roots of 3. Now, 2 square roots of 3 is fine and all, but it's not always the easiest number for us to deal with. So, in order to help us out with that, I'm going to write that down in this table here. I'm going to say 2 square roots of 3, but for graphing purposes, let's just go with, it's about 3.46. And folks, you can keep using the unit circle over and over and over and over. How I'd advise you do is start getting familiar with how to type this stuff into a calculator. So say, for example, I want to do pi over 2. I'm going to go to my calculator, and if you haven't used the TI-84 app on your Chromebooks yet, give that a shot. If you need some other tools, I know tools like Desmos do a pretty good job of this, so you can try that out. I'm going to go back to my main screen here. I'm going to clear this out. One thing we need to make sure we need to make sure we're in the Radian mode. So if you get a mode, then make sure the third one down here, so if I hit the down arrow, make sure the Radian is the one with the dark background and the light letters. So I'm going to hit enter just to verify. And hit second mode to get back to the main screen. And now let's just plug in, use the same formula to do 4 times the sine of our next theta, pi over 2. So we'll have 4 times the sine of pi, which is second raised to that, divided by 2. Close your parentheses, hit enter, and we end up with a value of 4. Plug in the next one. I'm actually just going to kind of copy that previous one because now we're just going to change it to 4 times the sine of 2 pi divided by 3 for our next theta value. We plug that in, and it's back to that same value that we had earlier, so it's about 3.46. Keep plugging in those numbers. You're going to start noticing some patterns. So like the next one, if we plug in 5 pi over 6, we end up with a value of 2. If we plug in pi, we end up with a r value of 0. Plugging in 7 pi over 6, we end up with negative 2. Plugging in negative 4, 3 pi over 2, we get negative 4. Plugging in 11 pi over 6, we end up with negative 2. And plugging in 2 pi, we end up with 0. You start to notice some repeating patterns here. Now, the graphing part of this, we're just going to kind of take it nice and slow. The first part, I'm actually going to biggie size this screen again. Go back to full screen so you can just focus on this. Okay. So, plugging in an angle of 0 degrees with a radius of, 0 radians with a radius of 0. So in other words, we're facing this direction. We're facing going to this towards this 0, and we got to walk 0 in that direction. Well, that's right there. It's right at that pole, right at that origin. Next up, we're going to face the pi over 6. We're facing that direction, and then it says we're supposed to go 2 out from the center. So we're going to face the pi over 6, go 2 out from the center, and we're going to plot a point there. Next up, we're going to face pi over 3, facing pi over 3, facing that direction, and then we're going to have to approximate the 3.46. So again, we're facing pi over 3, and we're going to go a little less than 3.5 away. So 1, 2, 3.5, just a little less than that. Next up, at pi over 2, so if we're facing this direction, we're going to be 4 away. So we'll go face that direction 1, 2, 3, 4 up. So we're going to have a point right there. Next up, 5 pi over 6. 5 pi over 6, again, facing 5 pi over 6, which is in this direction. And we're asked to go, oh, I'm sorry, I skipped a 1. 2 pi over 3, we're facing this angle, facing the 2 pi over 3. We're asked to go 3.46, so again, a little less than 3.5 away. Next up, 5 pi over 6. Now we're facing 5 pi over 6. We're asked to go 2 away. So 5 pi over 6 is 2 away. That's going to be right there. And then at pi, so if we're facing this direction, we're asked to go 0 away. So we're actually back to where we started. Now, folks, I got to break a habit, and this is something I'm hoping I'll fix for the next example. Connect your points as you go. So I'm going to start with this first point. This was our first point here. And I'm going to start connecting that. That was our second point, our third point, our fourth point, our fifth point, our sixth point, and our seventh point. Okay, so now we're at pi 0. Now 7 pi over 6. 7 pi over 6, we're facing this direction here. So facing in that direction, but we're asked to go -2. So instead of going like +1, +2 that way, we're going to still be facing the direction, but we're going to kind of walk backwards. We're going to go -1, -2. That ends up being the exact same point that we had. Interesting. Now, if I were to do 3 pi over 2, so again, if we're kind of like facing this downward direction here, we're asked to go -4. So instead of going 1, 2, 3, 4 in that direction, we're going to go backwards 1, 2, 3, 4 in that direction. So it's back at that same point. Folks, you can keep going. You're going to end up finding that we already have all these exact points plotted. You'll see right in this area, these points are kind of repeats. They end up being the exact same points that we've already plotted. So one way we can say that is they map to points we already have. So they map to points that we already graphed. In other words, we don't need to keep graphing. It's just going to repeat that same pattern over and over and over and over. So this picture here ends up actually being a circle with a radius of 2. Taking a look at this next one, we're asked to graph r equals 3 plus 2 times the cosine of theta. This one I didn't give you a table, but I'm actually going to make a table for you now. So we're going to plug in some theta values, and once we plug those in, we're going to get some r values, our radii values, radius values, if you will. So let's just start off with 0, and let's go pi over 3, pi over 2, 2 pi over 3, pi, 4 pi over 3, 3 pi over 2, 5 pi over 3, and 2 pi. Now again, this is where calculators are going to come in handy. We're going to do a couple of these by hand, but then we'll just do the rest on a calculator. So we have r equals 3 plus 2 times the cosine of our first theta value we're using is 0. That ends up being 3 plus 2 times. I'm going to go jump back to the unit circle. The cosine at 0, remember cosine is your x value. Well, the cosine at 0 is 1. So it's going to be 3 plus 2 times 1, which gives us 5. Next up, r equals 3 plus 2 times the cosine of pi over 3. So again, going to the unit circle, cosine at pi over 3, so the cosine up here is a half. So we have equals 3 plus 2 times that cosine of pi over 3, which was a half. So 3 times 2 plus 1 gives us a grand total of 4. Now again, folks, I would strongly suggest just using a calculator for the rest of these. You can use a graphing calculator, you can use a non-graphing calculator. Let me go back to my graphing calculator a second, show you what that is going to look like. Let me just, I'll leave it as is. So, there we go. Plug in the next one. We got 3 plus 2 times the cosine. Our next angle we were using was pi, so second caret divided by 2, and we end up getting a nice convenient number of 3. We keep doing that pattern. We got 3 plus 2 times the cosine of 2 pi over 3. So we got 2 times pi divided by 3. And folks, you'll notice I chose these numbers because they end up being pretty nice. I'm not going to type the rest of these out. You can do that for yourselves. But let's jump back to our notes here. And I'm just going to fill in the rest of this table. Again, feel free to use a calculator for this. So we end up with 3, then 2. The next one ends up being 1, then 2, then 3, then 4, then 5. There's a pretty nice pattern there. So going over this pattern, at an angle of 0 radians, so again, facing this direction, we got to go 5 in that direction. So we're going to go 1, 2, 3, 4, 5 is out here. Facing pi over 3, so facing over here, we're going to go 4 out, so that's going to go to the 4th circle. Pi over 2, so facing pi over 2, we're going to go 3 out, so our next point is there. Next point, facing 2 pi over 3, so facing this direction, facing that direction, we're going to go 2 away. At pi, so thinking about it in degrees, that's 180 degrees. So facing that direction here, we're going to go 1 away from the pole. At 4 pi over 3, so that's facing down here. 4 pi over 3, that's 2 away. Facing 3 pi over 2, so going this direction, we're going to go positive 3 in that direction. Next up, facing 5 pi over 3, so facing this direction, we're going to go 4 in that direction. And the last one, 2 pi. Well, 2 pi is a full circle, so we're actually facing back this direction again, and we're going to go 5 out. Well, we end up being in the exact same spot that we have been. So connecting those dots in order, this was our first point, our second point, our third point, our fourth point, our fifth point. So kind of drawing it as smooth of a curve as we can. It ends up looking a little something like that. Kind of an interesting shape. Kind of like curves in at that point right over here. Now, a couple tricks that you can pick up as you're practicing this more and more. It's not always going to be the easiest, but you can kind of speed this process up. If you can figure out which values of theta are going to give you your largest R value, which is going to give you your largest radius. So for example, in our case here, the largest radius that we ended up having was when theta equals 0 and then when theta equals 2 pi. And also which ones end up giving you a radius of 0. This example didn't give us a radius of 0. We're going to practice a couple more on the next page as well.